Good morning, everyone. Today we are going to present our project on signal propagation and power simulation. In this project, we are using the NS3 network simulator. The purpose of this study is to assess how signal propagation varies in different models and to measure power in mobile network. This work will help us to gain an insight into how different environments affect signal strength and coverage, and we are gaining essential factors in modern network, including wireless and wired. In this project, we are tasked to set up the NS3 simulator. This NS3 simulator is a tool which helps to simulate network, whether it is created virtually between two communicating entities or more. The objective of our project is to simulate and compare signal propagation models, specifically the free space and two-ray ground models, to understand the impact of environment factors on signal transmission and performance. In mobile networks, where maintaining consistent signal coverage is crucial, understanding how propagate under varied conditions is invaluable. This knowledge is key to efficient network design, enhancing coverage, managing interference, and improving user experience in urban, rural, and open landscape. Let's move on methodology that we have used to simulate this project. We conducted as our simulation using NS3 as talked earlier, a discrete event network simulator which is used for its realistic modeling of network dynamics. The two primary propagation models we focused on include free space model. This model is best suited for line of sight scenarios such as satellite links or rural areas with minimal interference. It calculates signal loss theory based on distance from the transmitter, offering simplified but a powerful model for open space environment. The second one is two-ray ground model. This model is designed for environment with both direct and ground reflected paths. This model is also more accurately represents signal behavior in urban and suburban areas by factoring in both the line of sight and ground reflection. The two-ray ground model provides realistic assessment of signal loss in settings where ground reflections significantly impact signal strength. Without moving forward, I would like to invite my colleague to continue with a further explanation. I welcome my colleague Ambroise talk about the codes, how it works, and further information needed. Ambroise, you, you can continue.
Can you hear me?
Yes, we can.
Okay, thank you. I'm going to talk about the code that implements signal propagation. Um, on my terminal, as you can see, there is make signal propagation between two nodes in NS3. creating and displaying the path flows between them. Here are breakdown of each main part of the code. So this code includes required NS3 modules. Um, as you can see, the first six line uh, display um, include statements, a load variables, NS3 module, each providing specific functionality like core that display essential function for the simulation. Um, and the second functionality of this include require is network that manage network node object. Other is mobility that set up the node position. Uh, the last one functionality of these include modules is Wi-Fi, define Wi-Fi network components. So the 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 second line it's about the logging that enable logging um, that provide for display message during the simulation. For example, there's logo info allow info level messaging to be printed out. The The, the next section uh, is the node container. This node container Wi-Fi node. Uh, okay, we have two node in node container called Wi-Fi node. This represent device in our simulated network. Um, Here are other section that called setup mobility for two nodes. Uh, this section uh, define the position using mobility helper, as you can see here, and list position allocator. Um, Other we have the press one node at uh, 00 position as origin and other at 100 uh, at 100 meter apart. Also, we have the line that set up constant position model to ensure they remain in fixed positions. Um, Other part is choose propagation model. At choose propagation model, this line select the signal propagation model. Um, so they have the functionality like long distance propagation loss model that simulate path loss based on distance between nodes. Um, Other functionality is constant speed propagation delay model that simulate a constant delay as the signal travel. Also, we have other part of um, that retrieve model that retrieve mobility models. Um, as you can see here on the on this lines, we have the part that retrieve mobility model. Um, this this part is used to fetch the mobility model for each node, which we will need to calculate the path loss. Um, Also, we have other part that calculate the output and path loss on on this line. As you can see here, here we calculate the output and path loss. Here, the car Lex power function calculate the received power in the cyber given transmit power and sent receive position. Um, Also, we have another another uh, another line that show the path loss in log. as path laws. Uh, for example, at the position of X, where X is calculate path loss in the suburbs. So far, uh, this is program that simulate propagation of signal between two nodes and calculate the loss of signal strength based on their distance. The output will be shown, the path loss will be in dB, allowing us to understand how much signal is lost over distance of 100 meters using choosing model. Um, After running this program, here we have the final output of signal propagation. As you can see here, there is the final output of signal propagation. So let me invite another colleagues to explain the summary about this. Thank you.
Thank you, Aaron. We are going to the next step. As we saw, our colleague has done much, which is good. And what we can say here, through these simulations, we aim to get an honest understanding on how signals behave under diverse conditions. The free space model is expected to overestimate signal strength in a clustered environment as it doesn't account for obstacles. On the other hand, the two-ray ground model, which considers ground reflection, is anticipated to yield more accurate prediction in urban settings with buildings and train obstacles. By comparing to these models, we can identify how network converges and signal strength adjust across different landscapes, which is critical for planning network infrastructure in real-world scenarios. What I can say within these implementations, this simulation project will provide us with a foundation understanding of relationship between propagation and uh, relation between signal propagation, perforce, and environment factors. This insight will not only guide us in terms of optimization of mobile networks for consistent coverage, but also support the network design of resilience network capable of meeting the demands of high density and remote location. And we like your advice and feedbacks. May my colleague, I want to ask if they can add some ideas or there is anyone who have question. Anyone?
There's no question on my end.
Yeah, thank you everyone. Yeah, that's good.